All right, everybody. So for lesson 11, 6th grade, module 5, Engage New York / Eureka Math, I highly recommend checking out my video called Volume and Surface Area. I break down using pictures what fractional edge lengths do to our unit cubes that are made with volume, since volume makes cubic units. And we're looking for, on the opening exercise, which prism has more regular 1 by 1 by 1 cubes. So when we multiply whole numbers, right, length times width times height, that is our formula for volume. You just multiply those three numbers. Whole numbers are going to give you a whole number response, and they're all going to create 1 by 1 cubes because you're literally cutting it into 10 inches this way. So you'd have, 1, 2, 3. These are terrible lines, but you get that there'd be 10 units within there, right? And there'd be 4 going up here, and then there'd be 6 coming across like that. And I know this picture is pretty terrible, but the idea is each of the cubes created are going to be 1 inch by 1 inch by 1 inch, and the top would also be cut. And then you'd be creating a whole bunch of these 1 by 1 cubes, right? Well, when they're fractions, you get something different. Okay, so I'm going to move on past our length times width times heights because we've already kind of done some of this. You can multiply these and figure out what they are. And then your units in these would be inches cubed because you have 3 dimensions, right? You've got the length going across. You can call this the length. You got the width going back, and then you also have the height. So you have 3 different dimensions versus with area, you only have length and width. You just have a square, right? Area is only going to give you 2 dimensions. We can only measure this 2 ways. We can measure it across and up, right? We don't have a back or a depth here. So 2 dimensions gives you inches squared for area, but 3 dimensions, 3 times, right? Cubes gives you cubic units, or to the 3rd power. So this is the question that really throws a lot of people off, all right? So we can find the volume of this pretty easily at 240 inches cubed, but that's 240 1 by 1 by 1 inch cubes, right? All of these broken into their equal units, right, by ones. So like we saw up top, gives us 240. But what if the dice we're fitting are smaller than that, right? A ½ inch is smaller than a whole inch. And so instead of it being 1 by 1 by 1, it's half by half by half. And what the big mistake a lot of people make is, oh, well, half is, half the size of this. And so that would make double, right, the number of these. So they'll say something like 480. That's how many, because these are half the size. But these aren't half the size because it's half on 3 different edges that are all being multiplied to each other. So again, it's half times 1/2 times 1/2 the size. What would 1/2 times 1/2 times 1/2 be? Right, it'd be 1/8, right? That's a 2. So it's actually 1/8 the size. Every one of those half by half by half dice is 1/8 the size of one of these. Okay, so I'm going to show you what that is over here. And again, the video volume and surface area breaks this down really well. So let's zoom in on this. So let's assume that this is a 1 by 1 by 1 inch cube. All right, this is the cubic units. 240 of these are what make up the big shape over there. So this would be 1 by 1 by 1. And again, what we're doing is we're going to cut each side in half, and we're going to draw that in. Okay, so if you view this as the front, right, if we take the 1 and we split it in half, right, now we have half and a half, which makes 1. We're going to do it this way. So that's a half. That's a half, which makes 1. Okay, so we're also going to have to do that, and we're going to have to do that, and we're going to have to do this, and we're going to have to do this. And you can start to see that, okay, let's focus just on this corner cube right here. Do you see this cube? All right, so this is a ½ inch by ½ inch by ½ inch cube. How many of these are in this 1 by 1 by 1 cube? Okay, 1, 2, 3, 4. And aren't there going to be 4, another layer behind it, because this line? So that's going to be 8. So there's 8 of those cubes for every one of the 1 by 1 cubes. So a good thing to remember here is that if it's half by half by half, okay, that's going to be equal to 1/8 of a 1 by 1 by 1. So for every one of those, there will be 8 of these. So what are we really going to do to the number 240? Yeah, we're going to have to multiply it by 8, right? We're going to have to multiply 240 times 8. And I'm just going to get rid of this right here, which is not going to let me, but that's okay. And so you're going to see 16, 17, 18, 19, 1,920 dice would fit into that box, not 480. So look at example 2 here. See if you can find the volume, right? The first step is to find the volume, multiply length times width times height, and then see if you can figure out if for these 1/4 inch by 1/4 inch by 1/4 inch cubes, again, if it's a cube, that means all sides are equal, right? How many of those would fit into that volume? So with length times width times height, we have two options. We can transfer these into decimal form, 1.5 times 1 times 3.75, or we can make them improper, 3/2 times 1/1 times 15/4, and then multiply. So either way, you're going to get 5 5/8 in fractional form, mixed number, inches cubed, or 5.625, which is 5/8 in decimal form, inches cubed. And again, these are 1 by 1 by 1 inch cubes, because these would be split into whole. We're multiplying them straight across. We're creating 1 by 1 by 1s. But if each of the cubes inside are going to be 1/4 of the side lengths, or each 1/4, that's going to be 1/4 times 1/4 times 1/4, which is what? 4 times 4 is 16. 16 times 4 is going to be 64. They are 1/64 the size. Okay? And so what I want to show you is how we're going to simply take that denominator 64 times, right, of these. So we're going to have to take this number and multiply it by 64 in order to find out how many of those 1/4 inch cubes. So do we want to do decimal form? We want to do fractional form? I'm going to do decimal form. So I'm going to do 5.625 times 64. And I went ahead and just did that to save time, but you remember we have 3 decimal place values in our problem, so we just set it up like 5,625 times 64, and then at the bottom when we're done, we're going to add 3 decimal place values. So our answer is 360, which is a lot more. In fact, it's 64 times more than the 1 by 1 by 1 cube amount that we have in there. So what does that look like? Here's a 1 by 1 by 1 cube, but let's cut it into 1/4 inches, right? So a 1 inch would be cut 4 times, right? These would each be 1/4 of an inch. Do you see that? Okay, and I'm going to do the same thing here. I'm going to do the same thing here. The same thing here. And the same thing on top. Every side cut 4 times. How many cubes is that going to create? Do you really want to count all these? Or do you want to trust that there's 64 of them? Because we can see one here, right? So let's just take this first layer. There's 16, right? 4 by 4. There's 16 cubes on the first layer. Then we have the second layer. There's going to be another 16, then another 16, then another 16. And 32 and 32 is 64. 16 times 4 is 64. So we would get a volume of 4 20 27ths centimeters cubed. Now, this question might throw you off, but it's really quite simple. You'll notice each of these are in thirds. So if they were smaller than 1, what would be the best size? Well, probably thirds. Because if you look at the problem, there's 16 of those, 2 of those, and 4 of those. So couldn't we just say that we're going to do 16 on that side times 2 of that side and times 4 of that side, since each one is broken into thirds, which is going to give us 128 centimeters, or 128 of those cubes at 1/3 by 1/3 by 1/3 centimeters. And so that's the answer to C, but the answer to D would simply be to say that 128, right, is going to be 27 times 4 and 20/27. Why do I say 27 times? Well, if they are 1/3 by 1/3 by 1/3, doesn't that equal 1/27th? Which means there's going to be 27 of those inside of each of the 1 by 1 by 1 cubes created by our original volume, which was cubic centimeters. So if I take that number and I multiply it by 27, I will get how many of those cubes will fit, the 1/3 by 1/3 by 1/3 cubes would fit inside of our original volume. So I always get that this is a really challenging lesson. This is a hard concept to understand. Again, go back and check out that other video. But if you look here at this problem set, your goal is to, if you have to rewatch this video and that video before starting it, then do so. But go ahead and try the problem set all the way through on your own. Then check back with the video, this video, to find the answers. All right? But don't just keep watching right now, because I'm going to put all the answers on in a second. All right, so pause it, go back and rewatch it, watch the other one, try this problem set on your own, see what you can figure out, challenge yourself, then check back with the video. All right, so hit the pause button now. So here are the answers to number 1. We have a volume of 56 inches cubed, and if they filled it with 1/3 inch by 1/3 inch by 1/3 inch cubes, we would have 1,512 of those. And that's related because it is 27 times the volume, and they're different because it is one of these cubes is 1/27th the size of a regular 1 by 1 by 1 cube that is created by multiplying length times width times height and getting the volume. And should she try to fill them with 1/2? I would say no, because of this picture right here. The reason 1/3 works is because in the side that was 1 1/3, that's 4/3. You get 4 equal thirds out of that, right? Each of these is 1/3. But if you had that same side and you divided it into 1/2 inches, right? You'd have 2 of those 1/2 inches, which is 1, but then you have 1/3 left over, which isn't going to give you another 1/2 inch cube. And so even though you'll get a whole number of cubes that would fit in there, you'll have to change the dimensions of the box in order for it to fit. So using 1/2 inch long cubes and things that are broken into thirds won't give you an exact fit. You're going to have some empty space and you're not going to be able to fit all of those cubes in there. The volume for number 2 was 288 centimeters cubed. And for B on number 2, it was 51 17/40 inches cubed, which I think is like 0.425, 51.425 inches cubed if you made these decimals. So that'd be 3.4 times 5.5 times 2.75. You'd end up with 51.425. Okay, so the answer to number 3 for A, which was 1/3, and how many more of the 1/3 unit length cubes would there be than 1/2, would be 228 more. Here are the numbers of how many of each cube, and then I went ahead and did the 1/4 in that same section to answer letter B. So the answer to B was 768 of the 1/4 inch cubes. Okay, and so for number 4, if we drew it out, right, 7 is 2 sets of 3.5, 14 is 4 sets of 3.5, and then 3.5 is 3.5. So we would end up having 8 of those boxes inside of one box that is being shipped. So if we did 3.5 by 3.5 by 3.5, we get 42.875 cubic inches. And if we multiply that by 8, because there's 8 of those inside of the whole shipping box, we get a volume of 343 cubic inches. And for number 5, we have to set it up as length times width times height, which would be 3.1 times 2.4, which is 7.44 times the width, would equal our volume. So we divide by the 7.44 and get that our width is 4.3312, and that's rounded, meters.